For literally thousands of years, ginseng has been this cornerstone of traditional medicine. But what happens when you take that ancient wisdom and put it under a super powerful modern microscope? Well, that's exactly what we're doing today. We're going to dive deep into the compounds hidden inside this legendary root and explore what they could mean for one of the biggest health challenges on the planet, cardiovascular disease. Let's see what the science has to say. So here's our game plan. We'll kick things off with the big picture, the global health challenge we're up against. Then we'll get to know ginseng's active compounds and see the internal battle they're waging in our bodies. After that, we'll break down their molecular defense system, look at what the tests actually show, and finally have a real talk about the promise and the hurdles.
All right, first up, a global health challenge. We really need to understand why we need new approaches to cardiovascular health in the first place.
Okay, let's just let this sink in for a second. Cardiovascular disease. It is still the #1 cause of death worldwide. We have some good treatments, for sure, but they just don't work for everyone. And that huge gap is what's pushing scientists to look, well, everywhere for new ideas, even in places we've known about for centuries. Which leads to this pretty mind-blowing question: what if a traditional herb held some of the clues to fighting the world's leading cause of death? So to even begin to answer that question, we've got to go to the source. We need to look inside the plant itself. It's time to talk about ginseng's active compounds and unpack the key ingredients of this legendary plant. Okay, so the real power players inside ginseng are these things called ginsenosides. You can think of them as the plant's secret weapon, the molecules that are actually doing all the heavy lifting. They're a special kind of compound, and get this, they are totally unique to the panax or ginseng family of plants. So whenever you hear about the amazing health effects of ginseng, what people are really talking about are these little molecules. But here's where it gets really interesting. Not all ginsenosides are the same. Not even close. I mean, just look at these structures. They come in different families, you could say, like these PPD and PPT types. And a tiny, tiny tweak to their chemical shape can completely change how they act in your body. And what scientists are finding out now is that some of the rarest ones might just be the most powerful of all. Okay, so we've met our potential heroes, the Ginsenosides. But every hero needs a villain, right? So what exactly are they fighting against? Let's dive into the body's internal battle and meet the hidden culprits behind cardiovascular damage. All right, the main villain in our story is something called reactive oxygen species, or ROS for short. Now, a few of these guys floating around is totally normal. But when you get too many of them, they cause something called oxidative stress. The best analogy? It's literally like cellular rust. Imagine your insides slowly rusting. This rust starts to mess up all the delicate machinery in our cells, and it particularly loves to attack our cardiovascular system. And believe me, this damage is serious stuff. Too much of the cellular rust can kick off bad inflammation that just won't quit. It can directly damage the inner lining of your blood vessels, it can cause cells to literally die off, and it speeds up atherosclerosis, the hardening of the arteries. So the takeaway here is simple. Getting that oxidative stress under control is absolutely crucial for a healthy heart. This is where our hero re-enters the story. How do ginsenosides actually fight back against all this cellular rust? Well, let's take a look at their incredible molecular defense system. Okay, so what the research is showing is that they use this amazing 1-2 punch. First, and this is the really clever part, ginsenosides don't just act like any old antioxidant. Instead, they flip a switch that activates our body's own super powerful antioxidant defenses, things like the NRF2 pathway. It's like they're not just fighting the fire, they're calling in the whole fire department. Then, for the second punch, they actively shut down the alarm bells of inflammation by blocking pathways like NF-kappa B. The end result? Less cellular rust and way less harmful inflammation. Pretty smart, right? And a perfect example of this is a molecule called compound K. Now, check this out. When we eat ginseng, our own gut bacteria get to work and transform the big ginsenosides into smaller, more potent forms, like this one. And compound K has become a huge deal for researchers because it seems to be especially good at all this anti-inflammatory and antioxidant work. So all of this sounds fantastic in a petri dish or in a lab, right? But the million-dollar question is, does it actually work in people? Well, there's only one way to find out. We have to put it to the test and see what the scientific evidence says. And that brings us to a really important study. It was a randomized, double-blind, placebo-controlled trial. Basically, the gold standard of scientific research. That means neither the participants nor the researchers knew who was getting the real deal versus a placebo. They were looking at the effects of a specific ginsenoside called RG3 in healthy adults. This is exactly the kind of high-quality evidence we need to cut through the noise. And the results? Honestly, they were pretty striking. Just 3 hours after taking it, the people who got the RG3 saw their blood pressure drop significantly compared to the placebo group. We're talking a 5-point drop in central systolic blood pressure. That's the pressure right at the heart, the really important number. And they saw drops in their regular arm blood pressure too. I mean, that is a direct, measurable effect on a huge risk factor for heart disease. But that wasn't even all. The same study found that RG3 also improved something called the augmentation index. Basically, that's a fancy way of measuring how stiff your arteries are. And you do not want stiff arteries. It makes your heart work way too hard. The fact that this compound could make arteries more flexible, even after just one dose, is a super promising sign for our overall vascular health. And it turns out RG3 isn't a solo act. A whole bunch of other studies, mainly in the lab and in animal models, have shown that there's a whole team of ginsenosides working to protect the heart. You've got RB2, which helps by reducing inflammation. Then there's RC, which reduces actual injury to the heart muscle. And RB3, which straight up protects heart cells from getting damaged. So it's not just one thing, it's this broad team effort from all these different compounds. Okay, so the evidence is definitely compelling, but let's take a step back. Where does all this leave us? It's time for a balanced look at the future, focusing on both the promise and the very real hurdles. On the one hand, the promise is huge, right? We're looking at compounds that could potentially lower blood pressure, make our arteries more flexible, and fight that root cause of so much heart disease, inflammation, and oxidative stress. But on the other hand, the hurdles are just as real. Not every single study has had these amazing results. Some of the best ginsenosides are incredibly rare and hard to get. Plus, our bodies sometimes have a tough time absorbing them. So the bottom line is, the potential is absolutely there, but we need more big human studies and smarter ways to deliver these compounds before this can become a mainstream therapy. And all of this brings us right back to where we began. It feels like modern science is finally catching up and starting to prove what traditional wisdom has been saying for centuries, that deep in the roots of the ginseng plant, there are some powerful secrets waiting. Now, the road from an ancient herb to a modern medicine is a long one for sure, but the science seems to be telling us it's a road we absolutely need to keep traveling down. So could the future of heart health really be found in these ancient roots?